Welcome all to my channel once again. Hope all are doing well. In this video I have discussed regarding the part 1 of MCA first semester regular and back semester question of C and data structure for the year 2021 and 22. The part 1 mainly consists of 10 questions and each question carries 2 marks. Now we have to discuss one by one. So first question is you have to represent the decimal number 2784 in binary and hexadecimal form. So here I have given the answer for it. The decimal number in binary form we are getting this one, and the decimal number in hexadecimal form we are getting this one. So how we are getting that result? Okay, now we will solve it right now. The question is 2784. okay, so 2784. suppose I want to find the binary number. Okay, it is in the form decimal, so I want to find it the binary one. So we have to divide it by 2. So 2 into 1 1, 2 into 1 2, 2 into 3 6, then 1 8, 2 into 9 18, then 2 into 2 4. So we are getting what? Remainder is 0. Again we have to divide by with 2. So 2 into 6 12, again 19, 2 into 9, that is 18, again 1 2 we are getting, 2 into 6, okay, 12 we are getting. So again the remainder is 0. Again we have to divide by 2. So 2 into 3 6, 2 into 4 8, then 2 into 8 16. Again I am getting remainder 0. Again we have to divide with 2. So what we have to get? 2 into 1, it is 2, then 2 1 and 4, 2 into 7 14, then 2 into 4 8. Again I am getting remainder as 0. Again we have to divide with 2. 2 into 8 16, then 1 4. So 2 into 7 14. Again I am getting remainder 0. Okay, again we have to divide with 2. So 2 into 4, then 2 into 3, remainder is what? Here I am getting 1. Okay, then 2 into 2 4, 2 into 1, that is 21. So remainder is again 1 I am getting here. Again we have to divide with, so let me expand it. Okay, so again we have to divide with 2. So 2 or 10 into 20, remainder is 1 again. Okay, then 2 into 5 I am getting remainder is 0. Then 2 into 2 I am getting remainder is 1. Again divided with 2. 2 into 1 2, remainder is 0. So what we are getting? Some backward side we will get the remainder whatever the value I am getting. So that means 1 0 1 0 triple 1, then 5 number of zeros. So that result we should get. So that is the answer actually, 1 0 1 0 triple 1, then 5 number of zeros. Okay, so that is the way to find out the decimal in means we have to convert the decimal number into binary. Okay, next second thing is you have to convert the same number into hexadecimal. So instead of dividing it with 2, we have to divide it by 16. So check here. So 2784 by 16. So 16 into 1. So out of 27 we are getting what? 7 11. Okay, 11, then 8 118. 16 into 118. Okay, so what we have write? 16 into, okay, let me calculate it. 118. Okay, 118 means 118 by 16 means 16 into 7. Okay, 16 into 7 we are getting 112. Okay, 16 into 7 we are getting 112, but it is requiring what? 118, 6 and 4. So 16 into 4 we are getting 0 here. Then again we have to divide with 16. 16 into 1, so that means 16 into 10 160. So what is the remainder? We are getting 14. So as it is in hexadecimal form already, we have known, means we are acquainted with that. A means in hexadecimal form, A means 10, B means 11, C means 12, D means 13, okay, E means 14, and F means what? 15. So here I am getting 14. So 14 means what? 14 means it is E, okay, and here I am getting 10 means it is A. So again reverse side we are taking the value. So finally getting what? A, E and 0. That is the hexadecimal form. So that answer is written here, A, E, 0. Okay. So in this way we can solve the first question. Okay. Now come to the second question. So second question is briefly write about the conditional operator with a suitable example. Okay, so here in a brief manner I have discussed here. So conditional operator is represented using question mark and colon. So that is the general syntax: expression 1 question mark, expression 2 colon, expression 3. That is the syntax for writing the conditional operator. So how it can be evaluated? First of all, we have to evaluate the expression 1. If it is true, then expression 2 will be evaluated, and its result will be the result of the conditional expression. Okay, if expression 1 is false, then expression 3 will be evaluated, and whatever the value you are getting by evaluating that expression 3, that is the output of the entire conditional expression. Okay, I am taking one example. So here I am taking A contains 10, B contains 20. Now here C is used for storing the result. Okay, so that conditional expression is written in this way: A greater than B. That means here A is 10, B is 20. So 10 is greater than 20, no. So no means we have to evaluate the expression 3. Okay, means this one, A plus B minus 7. That means 10 plus 20 minus 7. I am getting 23. So C will contain what? It will contain 23. Okay, so in this way we can proceed with question number 1, bit B. Now come to question number 1, bit C. Okay, so in C, what are the various types of real data type? Okay, real data type actually that means in bracket is clearly mentioned that floating point data type. So in C, generally we are dealing with these categories: float, double and long double. Okay, then question number 1, bit D. So what do you mean by int star ptr10? So here ptr is a pointer to an array of 10 integer, because here 10 is mentioned. Okay, next we have to come to question number 1, bit E. So what value strcab means string comparison function returns when two strings are same? That is the first case. And when two strings are different? So answer is, when two strings are same, then it will return 0, and when both are different, then it will return a non-zero value. Okay, next question number 1, bit F. We have to proceed with that part. So predict the output of the below program. So here that is the header file, whatever it is written, has include stdio.h. okay, then int main, int AR, the array name AR is the integer array name which contains 5 integer, which will contain 5 integer values. Okay, that means the size of array is 5 here. Now one assumption is given here. We have to assume that base address of AR is 2000, and size of integer is 32 bit. 32 bit means here 4 byte, because 1 byte is equal to 8 bits. Okay, now by taking this assumption, we have to print the value of error plus 1 and ampersand error plus 1. So in the first case, so what will get? Okay, so as percentage u means here we are getting some address here. So error plus 1 means, so we are assuming that what the base address is 2000. So error plus 1, so we have to compute. Okay, let me erase it. Or file new. Okay, so according to the question, we have to assume that the size of integer is your 32 bit. 32 bit means that is 4 bytes. Okay, and the base address is, okay, the base address is that is ARR value is what? It is 2000. Okay, now here we have to find out ARR plus 1. So we are getting ARR value is 2000 plus 1. Actually what will happen when we are performing the computation on address? So what will happen? So 1 into the size of data type. So here integer size we are considering 4 byte, that's why 1 into 4. So what we will get? 2004. So for first bit we are getting error plus, means for this we are getting 2004. Now when we are providing ampersand ARR, Okay, ampersand array means it will point to the entire, actually it will point to the entire array, and the array consists of 5 numbers. That's why array plus 1 means, so for entire array you have to consider, so the starting address is 2000 plus the array consists of 5 numbers, and each value is having 4 bytes. Okay, the size is 4 bytes, so 5 into 4, that is 20. Okay, so the total size is or the total value we are getting what, 2020. That's why in this purpose the result we are finding out. Okay, means in this way we are getting that result. Okay, so that is about question number 1, bit F. Next we will move to question number 1, bit G. Okay, so question number 1, bit G, you have to start. So write the C code to allocate space dynamically to a 2-dimensional array of size 20 cross 30. Okay, so let me explain in a brief way. Actually, how to allocate the memory dynamically in C? Generally, we are taking 3 functions for dynamic memory allocation. One is your malloc, okay, another is your calloc, and another is the realloc function. Okay, so either you can use malloc function or calloc function for allocation dynamically, and realloc is used for reallocating the memory. Okay, suppose you are allocating the memory using malloc function, then by the help of realloc function we can reallocate the memory. Similarly, we can also use the calloc function, but the style of writing or the syntax for malloc function and calloc function is different. Okay, so in this question, the question is given, we have to represent the 2D array of size 20 cross 30 in by using the dynamic memory allocation. Okay, that means 20 cross 30 means the row is your 20 and column is your 30. So here I am giving one approach. Okay, so here we are allocating the memory for 20 cross 30 2D array. Okay, so that is the syntax. So question is, you have to write the C code. Okay, but I am writing the complete program here. Okay, so here int main. So either we are considering that we are taking 2 variable R and C, R which contains 20 and C which contains 30. Either you can proceed in this way, or directly you can use 20 and 30 throughout the program. Okay, no issues. But if you are assuming the 20 and 30 to 2 variables, then that variable name should be mentioned throughout the program. Okay, so for allocating the memory dynamically, that point is very important. Int star p equal to int star malloc function I am using. So row into column into size of integer, means row is your 20, column means your C value is 30, and size of integer is 2 byte. Okay, so that in this way you have to allocate in the memory. Then by using this 2 for loop, okay, and that is the style of writing, star of p plus I into C plus j. In this we have to practice. Okay, by using this we have to assign the values, and we can, if you want to print the matrix value, again that format you have to use for I equal to 0 less than row, then I plus plus, again for j equal to 0, j less than column, j plus plus, then you have to print. In this you have to print, as it is the dynamic allocation, and you have to practice in this way, star of p, because I have used here p plus I into C plus j. Okay, so you have to go through in detail, because more number of programs are there. What means you can use that dynamic allocation mechanism, that means malloc, calloc and realloc function, and you can practice more number of programs using these 3 functions. Okay, now we have to go to question number 1, bit H. Okay, it is a theoretical question. You have to differentiate between linear and nonlinear data structures. So in a very simple way you can write it. So in linear data structure, what will happen? Data elements are arranged in a linear order, but here they are not arranged in a linear order. Where in non-linear data structure they are arranged in hierarchical manner. Okay, here single label is involved, whereas in non-linear data structure multiple labels are involved. Okay, in linear data structure the implementation process is easy, but here it is little bit complex. Okay, as compared to the linear data structure. Then data elements can be traversed in a single run only here in linear case. In non-linear case, data elements cannot be traversed in a single run only. Okay, so here memory is, in case of linear, so what is the problem? Memory is not utilized in an efficient way. whereas in nonlinear case memory is utilized in an efficient way. Okay, now the simple example of linear data structure is what? Your array, star, queue, linked list, and the examples of what? Nonlinear data structures are tree and graph. Okay, now come to question number 1. BPUT, actually it is one type of gate level question. Okay, suppose a circular queue of capacity n elements is implemented with an array of n elements, then we have to assume that the insertion and deletion operation are carried out using rear and front as array index variable respectively. Initially rear equal to front equal to -1. Okay, write the condition to detect queue full and queue empty. Okay, so by taking this assumption, when the queue is full and when the queue is empty. Okay, so let me explain you in a brief way actually how that condition is satisfied here. So what is the assumption here? The capacity of the circular queue, all of us know the circular queue. Okay, so I am representing a circular queue here. Suppose in this I am taking, okay, suppose the circular queue consists of 5 elements. So suppose that the starting is a 0, 1, 2, 3, 4. This is the index position, and in circular queue what will happen? The last one is connected to the first one. Okay, so here we are assuming that the capacity of the circular queue is n. Suppose I am considering n is equal to 5 and the index positions are like that 0, 1, 2, 3, 4. Okay, now the question is in which case, okay, we can also represent the circular queue in this way. In this we can represent, okay, index number 0, index number 1, index number 2, index number 3 and index number 4. In this also you can represent, that is the circular queue. Okay, that is the first one, that is the last one, both are interconnected. Okay, so as for the rule, so when the circular queue is full, that condition you have to check, we have to check, and when it is empty. Okay, so when it will be full, suppose that is the end where we are inserting the value. Okay, that is known as the rear end, and the end where we are deleting the value, that is known as the front end. Okay, and here we are assuming that rear equal to front equal to -1. So the end where we are inserting the value, that is the rear end. Suppose that is the rear end, and the end in which we are deleting the value, that is the front end. Okay, suppose I am inserting 5 elements, 10, 20, 30, 40 and 50. So first 10 will be inserted, so it will move to 0th position or 0th index, then 20. Okay, when we are initially rear and front both are at -1 position. Okay, but after inserting value, okay, now both front and rear, okay, will what is the value of front and rear? It is 0 for both cases. Okay, now when I am inserting 20, now front is 0 because no deletion operation is performed yet. So that's why the rear value will be incremented. So rear becomes 1. Now it is pointing to 1. Now after inserting 30, okay, the rear will pointing to, means what is the rear value? It is 2. After inserting 40, now rear value is 4. 3. Then after inserting 50, the rear value is what? It is 4. Okay, now what will happen? So what is the general format actually? Now in this condition all the places are filled here. Okay, that means that queue is full. Okay, so in this case what is the condition I am taking for general for all cases when the queue is full? Okay, I am taking the generalist formula, rear plus 1 mod n. So we have to take rear plus 1 mod n. So now what is the value of rear here? Rear value is 4 plus 1. Okay, mod n. What is the value of 5? Mod 5. That means 5 mod 5. So mod means we have to find the remainder. Okay, we have to find the remainder. So 5 mod 5 means the remainder is 0. Okay, so that thing is written here. So rear plus 1 mod n means in this example we are getting the value is 0 is equal to front. Obviously the front value is what? 0 here. Now 0 is equal to 0. That's why the condition is satisfied. Similarly, it is all of you know regarding that when the queue is empty, when rear equal to front, that means when no value is available, obviously the rear equal to front. So that is the condition for queue empty. Okay, now the last question of your part 1. that is it is also one GATE question. Okay, a single array A, that means it will be started from index 1 up to max size, is used to implement two stacks. The two stacks grow from opposite end of the array. Variables top 1 and top 2, and condition is top 1 less than top 2 point to the location of the topmost element in each of the stack. If the space is to be used efficiently, write the condition for stack full. Okay, the question is very long, but the answer is very easy actually. So in a easy way I am explaining that means how we are getting top 1 equal to top 2 minus 1. So so let me take one example. Suppose that is the stack. Okay, so it will consist, suppose it will contain 4 elements and it will be started from 1. So 1, 2, 3 and 4. Okay, so we are starting from 1 and the maximum size is what? Suppose 4 here. Okay, and it will contain 4 elements. So as the stack will grow from both sides. Okay, so top 1 is less than top 2, that's why I am writing top 1 here. Okay, and here it will move to, suppose I am inserting 10, 4 elements I want to insert. Suppose it is 10. Now top 1 will point to 10. Suppose I am storing 20 here, so top 2 will point to the index number 4. Okay, suppose I am inserting from top 1 side. Suppose it is 30. Now top 1 becomes point to what? Second position. Suppose I am inserting from this side. Suppose it is 40. Now top 2 become pointing to position number 3. So now what is the status? Now the stack is full right now. Now no places are there to insert another number. Now the stack is full. So now what is the condition for it? Now top 1 is less than top 2. That's why in this scenario, if I am writing top 1 is equal to top 2 minus 1, then the condition is satisfied. Check the result. Top 1 means what? It is 2. Top 2 means what? Now right now it is pointing to 3. So 3 minus 1. So 2 is equal to 2. Okay, so top 1 is equal to top 2 minus 1. So that's why we are getting the answer like that. Top 1 equal to top 2 minus 1. Okay, so in this way we have discussed the 10 questions of the part A of that MCA syllabus C and data structure of 2021 and 22 previous year semester question. Okay, so that's all for this video. Thank you all.